Hi everyone, today we're going to start using the Grammy library, which is a text generation tool using a predefined template. It is a JVM re-implementation of the tracery tool, which is available in JavaScript. I think it was developed by Kate Compton. So this JVM alternative takes quite a lot of the concepts from the JavaScript implementation and builds other things on top of it, introducing some cool mechanics around actions that can be used in text and regular expressions and all the cool things, which we'll get to at some point. For now, I'll just use a very simple example. I'm going to quickly create the example, run it, and then explain what that does, because it's much easier to see what the result will be once we've run it. We're going to add a symbol, which is going to take either that or that. And then we'll have the origin, which will point to this one. We flatten the result, and then we show what the result is. We flatten from origin. Okay, so this is more or less the minimalistic example that you can produce. We've got a grammar object. We add some symbols to it. We flatten on a particular symbol, which is like the start, and then it produces a string. Let's run this and see what it delivers. So when we first ran it, it gave us a B. Let's try running a couple of times to see if we get an A as a result. Cool, there's an A. Now, it should give you an idea of what's happening, more or less. Each symbol has essentially two parts. The first part is the key for that symbol, and the second part is the expansion of the symbol, or rule set, as it's called. Possible values of a key. So if you think about this being a data structure, it's actually kind of similar to a map. But in a map data structure, you typically have a key and a value associated with that key. In a symbol-based data structure, you have the same key, but the values, it's not a single value, it's a list of values, and you don't know which one you're going to get. And using this randomness, you can produce a range of possibilities for a string of text, right? So the simplistic expansion of this S of these possible values, A and B, produces one of them when we expand on this S key. If we add something else like C, we are adding another possible value for that expansion. So S, when expanded, could become one of these three values, A, B, or C. And this is not just for a single letter. So let's think kind of use cases. Suppose you want to say greeting. So greeting is going to be your key. I'm going to expand on that key. And that greeting could be hello. It could be something like hi. And it could be hey there. All possible greetings. And when you expand on one of them, you're going to get back one of the possible values. So that is essentially the core concept. You have a key, which is predefined. It's something that you know. You're also predefining possible values, but the actual value they're going to get when querying the key is not deterministic, unless you provide a random seed, in which case you will know what's going to happen down the line. So suppose you're making a chatbot or something similar, or you might be producing an email generation tool. So you can, create the body of the email, but some things you can leave for this thing to pre-generate if you want. Let's try a slightly more complex example. Let's add another symbol, which is something like language, possibly. And then you can have something like C++, Java, Kotlin, and you can also, when expanding a symbol or symbol key, so when we want to expand language, we can add modifiers. You can add something like this, for example. So you're basically saying we're going to have an article in front of whatever this is. So probably this is not a really good example. I'll pick something different, something like animal. So cat, dog, and I know, a bird. If you're expanding this as is without this extra notation, then you're going to get something like hello from cat. There is an article missing between from and cat. And by adding this modifier, is what it's called, you can add an article in there. Oh, I'm still expanding language. I need to expand animal. Okay, that probably needs to be inside. It's been a while since I implemented it, so I'm missing some terminology and syntax. Okay, so we've expanded greeting into one of these, which is hey there. We expanded animal to, it seems, dog, and there is now an article that goes in front of it. And if there is a vowel in front of the word, so if it begins with a vowel, basically, then that should auto-expand to an, so an animal. So these are modifiers. Let's do something a bit more interesting, something like creating runtime symbols. And there is no difference when it comes to ordering these things. You can create them as necessary. And the use case I'm sort of leaning towards at some point, not in this video, but sometime later, once the API is more or less stabilized, is being able to produce random programs in a language. You can define a template such that it conforms to a valid, syntactically valid program in a specific language like Java. And what we could do is then generate random compilable Java programs, which is quite cool. I mean, they're not going to be very kind of complex, or they're not even going to produce anything meaningful. It's going to be quite interesting to see what can be produced. Let's add, so for example, you could add a name here. Adam, Alice, But this is us adding the symbols before this flattening function is run. What we could do is create an action or create a symbol at runtime by an action. So actions are things that create symbols. We could say something like name, Adam, or Alice. Actually, I don't know if that is syntactically correct, so let's just try that. And because this is just an action, it's going to be performed, but you won't see any output from that. So what we can do is just have greeting from animal, but this would have been created as a symbol, so I can use it now actually no, I'll just do a full stop and then do something like name says, and then another greeting. Yeah, so I'll just reuse one of these, then full stop. So we've got 2 sentences there. So hello from a cat, and then Adam says hello as well. This symbol, which is name, was created dynamically using this action. Because when the whole thing is running, there is no symbol that we created that is called, that has a key name. So this was created at runtime by an action. This gives you an example of how you can create and also modify in the future various symbols at runtime. Now let's just try this. Is this going to work or not? Oh, that is pretty cool. Yeah, so you can use the same syntax for adding multiple values for an action for a symbol. I really need to get my syntax and terminology right. So this is the symbol that was created, and essentially this action is an equivalent of this piece of code. Right, let's do one final thing and then we'll stop. I'll have a think about how to express this in a more formal way, and then we'll do a few more tutorials on what you can actually get out of this Grammy tool. Shall we do an optional? Yeah, I think that could be our last example. So this is getting long. Let's move this over here. And let's turn the second greeting into an optional. An optional modifier is going to keep or not keep the expanded key or expanded symbol. So sometimes, and if you don't provide a value, it should be a 50-50% chance. So in one of these runs, this will not be there, or should not be there. Yes, there you go. Adam says, and there is no output there because this thing, this modifier optional, is saying to only include it if the chance passes, and the chance being by default 50%. You can specify your own chance if you want. It's quite useful for things like adjectives. Sometimes in your text you may produce or use those adjectives, and in other piece of text you may omit them. So it just gives you a variety of things. Similarly, you can already write a piece of text and store it so that you can use for later. Or you can completely, generate stuff at almost fully randomly. Because if you think about it, you could just go, this is a noun, and then provide a list of all nouns from a dictionary. There are various dictionaries available online that give you their text in plain text format. Read that, put it into here, because that is basically a list of things. So whenever you can use, if you have a list, just put it there. Do the same for verb. I'll just add a simple example so we can see where this is going. A noun, computer, keyboard, and display. Verb, crash, run, fly, swim. And then instead of all of this stuff, let's expand on noun, verb. That should take one of these nouns and that should take one of these verbs. And then you'll have a admittedly small sentence, but it is going to be somewhat fully randomly generated. Now imagine generating long pieces of text with that, which you could easily do. And I think there is an ES modifier that allows you to modify verbs so that it's not display crash, but display crashes. Let's try. It's not ES, maybe just S. Yeah, computer crashes. So instead of using the verb as it's written, it's taking it and then adding the correct suffix, I think it's called, at the end. That makes it sound, normal, syntactically correct English, I suppose. Computer crashes, and if it was something different, it keeps picking crashes, but there are other things. There we go. Keyboard swims. So it sounds a bit more interesting that way. And, there is some stuff that you can use this for. And I'll try to identify clear use cases as well as syntax and possibly produce a formal document which outlines everything and how it should be used. And then we'll go from there to cover more sophisticated tutorials, if you will. That note, let me know if this is something that you'd like to contribute to. It's written in Kotlin. It's literally just 2 files, I think. So it's reasonably simple in terms of the implementation. And if there is anything you want to know about this, or if you want to integrate this into your own application, just send me an email or something and we'll figure it out. All right, see you later.